station for 1,700 days.
Disclaimer: the content on this channel is meant only to provide helpful insights, tips, and information on certain subject or topic. While we strive to provide accurate and up-to-date knowledge, this is not a substitute for professional advice. Always consult a qualified expert or professional for your specific needs. We encourage you to use this content as a guide for learning and additional information. If you think this does not fit what you want, please skip the video.
Geothermal energy is the process of tapping into the heat stored within the Earth to generate electricity or for direct heating purposes. This energy comes from the natural heat beneath the Earth's crust, primarily due to the radioactive decay of elements and the residual heat from the planet's formation. Here's a step-by-step explanation of how geothermal energy is harnessed for human use. The heat from inside the Earth is generated from various sources: radioactive decay. Elements like uranium, thorium, and potassium deep within the Earth's mantle and core undergo radioactive decay, releasing heat, residual heat, leftover heat from the Earth's formation over 4.5 billion years ago. Gravitational pressure. The compression of Earth's interior creates additional heat. This heat gradually moves toward the Earth's surface through processes like conduction and convection, warming underground reservoirs of water and rock. Geothermal energy is typically tapped from geothermal reservoirs located near the Earth's surface, often in regions where tectonic activity brings heat closer to the surface, such as near volcanic areas, hot springs, and geysers. Over time, underground reservoirs of water absorb heat from the Earth's crust, becoming extremely hot. These reservoirs can exist as hot water, steam, or a mix of both. Geothermal power plants are often built in areas known as geothermal hotspots, where the Earth's heat is particularly accessible, such as Iceland, the Philippines, New Zealand, and parts of the western United States. There are several ways to tap into geothermal energy. Direct use of geothermal heat. In some cases, hot water from geothermal reservoirs can be piped directly to heat buildings, greenhouses, or for industrial processes. For example, in Iceland, geothermal heat is used for space heating, swimming pools, and even to melt snow on roads. Geothermal heat pumps, also known as ground source heat pumps, take advantage of the relatively constant temperatures just below the Earth's surface, which are around 10 to 16 degrees Celsius or 50 to 60 degrees Fahrenheit, to heat and cool buildings. In winter, the pump extracts heat from the ground to warm buildings, and in summer, it transfers heat from the building back into the ground to cool it. Geothermal power plants, or electricity generation. The most common and large-scale way of harnessing geothermal energy is by converting it into electricity. This process usually takes place in geothermal power plants. There are three main types of geothermal power plants. Dry steam power plants. These plants tap directly into underground sources of dry steam. The process works like this. Steam from the geothermal reservoir is brought to the surface through production wells. The steam drives a turbine connected to a generator producing electricity. Afterward, the steam condenses back into water and is re-injected into the ground to replenish the reservoir. An example of this is the geysers in California, which is the largest dry steam field in the world. Flash steam power plants. This is the most common type of geothermal power plant. The process involves high-pressure hot water, usually above 182 degrees Celsius or 360 degrees Fahrenheit, being pumped from deep underground. When it reaches the surface, the pressure drops, causing some of the hot water to rapidly flash into steam. The steam is then used to drive a turbine, generating electricity. Any remaining water and condensed steam are re-injected into the ground. Flash steam plants can be found in countries like the Philippines and Indonesia. Binary cycle power plants. These plants are used when geothermal water is not hot enough to generate steam directly. Instead of using the geothermal water or steam to drive the turbine, the geothermal fluid is passed through a heat exchanger, where it heats a secondary fluid, like isobutane or pentane, which has a lower boiling point than water. This secondary fluid vaporizes and drives the turbine to generate electricity. The geothermal fluid is then re-injected into the Earth to maintain the reservoir. Binary cycle plants are used in places where geothermal resources are moderate in temperature, such as in the western United States. Sustainability of geothermal energy. Geothermal energy is considered a renewable resource because the Earth continuously produces heat. With careful management, geothermal reservoirs can be sustained over long periods by re-injecting water back into the ground to replenish the reservoir. Geothermal power plants produce minimal carbon emissions compared to fossil fuels. However, they may release small amounts of sulfur dioxide or carbon dioxide from the Earth's crust. Challenges in geothermal energy. While geothermal energy is a highly efficient and reliable source of power, there are some challenges. Geothermal energy is geographically limited to areas with accessible geothermal reservoirs. Drilling and building geothermal power plants can have high upfront costs, though the long-term energy production is cost-effective. In some cases, drilling and reinjection can trigger small earthquakes, known as induced seismicity, although this risk is generally manageable with proper techniques. Conclusion. Geothermal energy harnesses the Earth's internal heat, which can be accessed through direct use for heating or through power plants to generate electricity. This energy is sustainable and renewable with a relatively low environmental footprint. By using advanced technologies like dry steam, flash steam, and binary cycle power plants, geothermal energy provides a reliable and clean alternative to traditional fossil fuels.